All right, guys, so we're starting to graph all of these different polynomial functions, and we have a whole bunch of different degrees that we could start off with. So previously we've graphed parabolas, and they're all second degree, and so we can have this technique that we use for every single parabola. Well, polynomials, they're all going to look different because you've got different degrees that you could have. The leading coefficient could either be positive or negative, so you've got tons of different options. So our best method that we can use so far is just by plugging in some different values into a table and kind of seeing how the graph takes shape. So one thing that's super important, and this is what I just mentioned here, make a table and then connect them. Knowing the end behavior will assist you in completing the graph. So we're still going to write that down just like we did in the previous section. So we're going to look at this leading term, and this leading term is going to tell us everything we need to know. So if you look back at the previous section, what we just had here was an odd degree with a negative leading coefficient. So we know that this is supposed to be the end behavior right here. So I'm just going to copy that down onto our new problem. So this is our end behavior, just so we know what to expect. Okay, so two things. Because it's odd, we know that we're doing opposite things on the two ends of the graph, and then because our leading coefficient is negative, we know that these are opposite from each other. Like as we go to the right, we go down. As our graph goes left, it goes up. Okay, so that's what we know from the fact that this is a negative odd leading term. So we copy that from the previous section. Now we're going to make our table of values. We're going to start with kind of a standard -3 to +3 and then see if there's anything else that we should plug in. Okay, so start with this. -3 to +3 is going to be your standard, and then, like I said, we can kind of go from there if we need to show anything else. So those are the x values we're going to plug in. I'm going to show you guys a wonderful trick that I highly suggest you use. So what I want you to do is go to a calculator page, and it doesn't matter, you can either add a calculator page to your current document or just stay with your current calculator page. Okay, so we've got a calculator page. We're going to define our function, and then we can just plug it in super easily. So hit this menu key right here, and then you're going to just take that first menu, actions. You want that actions menu. So if you've got your calculator, do this with me right now so you can practice. And then define. So it's just menu 1, 1. It's super, super easy. And then we're going to type this in, exactly what's written here. So f of x, take f off of the alphabet pad down at the bottom, parentheses, x, close the parentheses, the equals is up here, and then just type this function in. So negative x to the third, and then minus 4x to the second, plus 5. So you just type your function in. When you hit enter, it'll just say done. And then for all of these, you can just type in f of -3, just like that notation that we've been using. So you type that in and then hit enter, and it'll give you the value. We don't have to, spend any time plugging these in by hand because that would be painful. F of -2, we get -3. F of -1, we get 2. F of 0, oops, I forgot my parentheses. Make sure it's in parentheses. It's 5. F of 1, 0. F of 2 is -19. F of 3 is -58. Okay, so you can see the end behavior happening. Here we say the bigger the x values get, as x values go off to the right, f goes off to -infinity. That's what's happening there. We're also supposed to go off to the left and see our graph shooting up to +infinity. We didn't see that, so let's plug in another value or two. Try 4 or 5 just to make sure we can see that end behavior happening. So plug in, -4 and -5. So f of -4 gives us 5, and f of -5 gives us 30. Okay, so there it is. So we can see our end behavior here. So we're not going to plot these huge points. We'll probably plot these ones and then probably that one. Okay, so we'll do a quick sketch. Okay, so we've got the point -3, -4. That is right there. We've got the point -2, -3, -1, 2, 0, 5, 1, 0, 2, negative 19, so that would be way down there, so we're not even going to plot that one. And then jump here, we've also got negative 4, 5, so that is up here. All right, so just do your best to kind of connect the dots here. So we know off to the left, it should be just shooting up like this. And then it does this. Comes up to this point, turns around, and then it's just going to go down towards negative infinity. So it's going to look something like this. And we're just going for a sketch. It doesn't have to be perfect. All right, so the next thing we're going to mention is something called the location principle. It helps us to find x-intercepts. And like I said, we did this with the previous chapter. We did it just with parabolas. But most of these, you couldn't solve them by hand even if you wanted to, and there's no quadratic formula or anything like that. So the location principle says this. If f of x changes sign, from one x value to the next, changes sign means like it goes from positive to negative or negative to positive. There's an x-intercept between those two x values. And now we've got 0. We could call them 0. We could call them x-intercepts. Okay, now I'll kind of explain based on this graph right here. So you can see like right here, my function changes sign. I have a negative y value, then a positive y value. So that means there must be a 0 somewhere between these two. And there is. If you look on the graph, here's negative 2, here's negative 1. It does cross through the x-axis somewhere in between. And then if we look for another sign change, there's another sign change right there. And this is actually, well, here's the positive one, here's the negative one. So we know it crosses somewhere between 0 and 2, and we know it crosses right here because we actually come up with 0. And then if we trace back to, let's see, this is hard to see, but between negative 3 and negative 4, so since I wrote them in different places, negative 3 I have a negative y value, and at negative 4 I have a positive y value. So you can see there's another x-intercept between those two. So that's what the location principle tells me. So I'm going to look at a table on my next equation here to see if I can find all the real zeros. Okay, so we are going to plug this in and make a table out of it. So menu and then 1, 1 to define, and we'll type this in. So f of x, you type it in exactly as it's written, equals x to the 4th minus x to the 3rd minus 4x squared plus 1. So again, you hit enter, it'll just say done. So let's do our standard negative 3 to 3. We'll see if we need to add on any more. Okay, we're just going to plug those in. So f, and then in parentheses you put whatever you want to plug in. Okay, so we got, 73. Okay, f of negative 2, 9. F of negative 1. So there's a sign change. We got our first sign change right there, so we know there's going to be a 0 somewhere in between those two values. F of 0, we got another sign change. So then it goes from negative 1 to 1, so there's another 0 right there as well. F of 1, and another sign change, that's another 0. So that is negative 3, so again we've got another sign change there. F of 2, got negative 7, no sign change, so it's still down below the x-axis. F of 3, 19, there's another sign change. Okay, so those are all of your sign changes. So that is where all of your zeros are going to occur. Okay, so between negative 2 and negative 1, so we had a sign change, and then between negative 1 and 0, again between 0 and 1, and then again between 2 and 3. So that's what the location principle tells us. So just quickly we can plot these points and get a sketch. Okay, so I'm not going to plot this point, it's way too big. I can plot this one though. Let's go by 2, 4, 6, 8, 10. So here's the point negative 2, 9. point -1, -1, 0, 1, 1, -3, 2, -7, so this is 2, 4, 6, 8, and then 3, 19, so that would be higher than that. Okay, so it's going to look something like this. It'll come down through this point, up, down, and back up. Okay, so it is an even power, so it should be doing the same thing on both ends, and it's a positive even power, so it should be going up on both ends. And you can see we have these 1, 2, 3, 4 zeros that I mentioned, and they fall exactly where we predicted they would based on the table.